In their tongue, he's Dovahkiin, Dragonborn.
So, let's say if there are a man staying at a height of 10 meters and the man is dropping the ball for 10 seconds, and by the meaning of dropping or the maximum height, if the maximum height v is 0 but from dropping u is 0, so we can say that initial speed will be 0 and we want to find velocity. So we can use the formula v equals to the initial speed plus the gravity is 10 and the time is 10. V is 100 per second. So as you can see, by plotting or managing the positive or negative number can change the number of the output or the result. So as you can see, the gravity is matter and the acceleration is matter. So if we say that the gravity and the acceleration is equal, the unit of this one are equal to meters per second squared, but the unit of velocity is squared and not squared. So thank you for listening. Times t, s equals to ut plus 1 over 2 at squared, and v equals to u squared plus 2as. S equals to ut minus 1 over 2 at squared. So as a formula is here, we can see that there are variables that we can find from this one. So as in the formula one, there's no s in this one. In the formula 2, there is no acceleration in this one. In the formula 3, there is no velocity in here. In this one, there is no time, and in this one, there is no velocity. So from this information equation, we can use it's in such as that there is a box, and the box is traveling at speed of 30. So that we want to find its acceleration, and its time of traveling is 5, and the velocity is 40. So if we want to find the acceleration, we can plot this one into 30 is equal to 30 plus a, we don't know, 5. We move this one into this one, equal to a times 5. 10 equals to 5. A is equal to 2. So we can learn that if the acceleration is in this way and the way of the box is moving is the same direction of the acceleration will be positive. But if the acceleration is negative, we can say that the speed or the velocity is decreasing, or moving the other way. So in the free fall or from dropping, the A descends into G. G is equal to 10. 10 S squared. And the S of the box is moving, is the same direction of the acceleration. The acceleration will be positive, but if the acceleration is negative, we can say that the speed or the velocity is decreasing or it's moving the other way. So in the free fall or from dropping, the A descends into G. G is equal to 10. 10 S squared. And the S turns into height from the dropping. So as we can tell it, but there is another condition for the free fall. The free fall, they said that if the object is moving down in the direction with the gravity or the same direction of the gravity will be plus. But if it's throwing upward, the direction is against the gravity. The gravity will be negative.
Hello, and for the physics project, I'll be talking about dynamics, and the topics would be pressure, laws of motion, friction, and inclined plane. So let's start with pressure. So pressure is a continuous physical force exerted on or against an object by something in contact with it. So the formula for pressure is force over area, and for the liquid pressure, the formula for fluid would be rho GH. Rho is density, G is gravity, and H is height. And for example, says that calculate the pressure produced by a force of 200 newtons acting on an area of 2 meters squared. So we use the formula pressure equals to force over area. So pressure equals 200 over 2, and so pressure equals 100. So for the next topic would be laws of motion. Okay. So laws of motion comes from Sir Isaac Newton. So the first law of motion states that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an exerted force. So the key point here is that if there's no net force acting on an object, then the object will remain its constant velocity. Okay, so the second law explains how the velocity of an object changes when it's subjected to an exerted force. And the third law states that for every action there is an equal and opposite reaction. And the third law can be used to explain the production of thrust by a jet engine also. And for the next topic would be friction. Friction means a resistance force when objects move over another. An example for that would be a pen. We use a pen to write. So the reason why it works is because of friction. If you don't have friction, you can't even drive, because when you drive, your car the tires need friction from the road also, so it can move. Okay, so the formula for friction would be mass times acceleration, and another formula would be force equals to mu n, and this is coefficient of friction, and this is normal force. So to find normal force would be mass times gravity. Okay, so the last topic would be inclined plane. So what's an inclined plane? Inclined plane is basically a tilted surface like this. So the formula would be, you need to find the force that makes the object slide down the surface. So the formula would be mg sine theta, and to find the normal force here is mg cos theta. Okay.
Hello, my name is Ekasisu from 4A number 9. Today I'm going to talking about equilibrium and torque. Equilibrium is the state that describes a particle that the vector sum of all force acting upon the particle is zero. The first condition of equilibrium: if the sum of all force acting concurrently on a body is equal to zero, then the body must be in static equilibrium mathematically. Sigma F equal to F net equal to 0. Sigma Ff equal to 0. Sigma Fy equal to 0. Here, some exercise. How to find F1? We use sigma Fy equal to 0, then 15 minus F1 equal to 0, and then F1 equal to 15. We do the same for F2. 20 plus F2 minus 30 equal to 0 here. So negative 10 equal to negative F2. F2 equal to 10 Newton. Torque is defined as a force multiplied by the perpendicular distance from the line of action of the force to the pivot. Torque equal to force times perpendicular distance from the pivot. When the line of action of force make an angle theta from the moment arm, use torque equal to F times distance sine theta. Another formula is torque net equal to all torque subtract together. Some exercise. Calculate the force required to produce 20 Newton meter torque at an angle of 53 from along at 300 cm rod. So 20 is torque. Torque equal F times distance sine theta. So here 20 equal F times 3 sine theta, and 20 equal F times 3 times 4, 5. So F equal 8.34. Another exercise. A. Find the torque produced by each force. For F1, the distance is 2, so F1 torque equal to force 1 times distance, so 40 times 2 is 80 Newton meter. And torque 2 we use another formula. So torque 2 equal to F2 times R times sine theta. Torque 2 equal to 12 Newton meter. For torque 3, there is no torque because distance is 0 here. B. Find the net torque acting on the door. So net torque equal to torque 1 minus torque 2, then minus torque 3. So 80 minus 12. So net torque is 68 Newton meter. Second condition of equilibrium. The second condition for equilibrium state that if an object is in rotational equilibrium, the net torque acting on it above any axis must be 0. Sigma torque equal to 0. A 2 meter long rod which is suspended by a rope is at rest as shown in the figure. If its weight is 120 Newton, what is the tension T in the rope? So sigma T equals 0. Then sigma torque clockwise equal to sigma torque counterclockwise. F1 is here 120. Sigma T equals 0. Then sigma torque clockwise equal to sigma torque counterclockwise. F1 is here 120 Newton meter. 120 Newton. F1 times R1 is torque clockwise here. And F2 times R2 is torque counterclockwise. So F2 is T times sine 37. So just solve it. 120 equal to T times 305 times 2. So T is 100 Newton. A simple beam bridge across a stream is supported at its end by rigid blocks 4 meters apart. The beam itself weighs 800 Newton. What are the reaction forces at each support if a man of weight 700 Newton stands on the beam 1 meter from the lift hand support? So torque clockwise equal to torque counterclockwise. Torque 1 is here and torque 2 is here. It is clockwise and torque 2 is counterclockwise. So 700 is the man weight times by 1 meter here, plus 800 is the weight of the beam and the distance is 2. So 800 times 2 equal to F2 is the force here times 4 meter. Here to here 4 meter. So 700 plus 1600 equal to F2 times 4 meter. So F2 is 555 Newton. And we have to find F1 here. So sigma F equal to 0. 800 is the beam weight and 700 is the man weight here. 800 plus 700 equal to F2 plus F1. So F1 is 925 Newton. This is spring constant. Force equal to spring constant time the amount of extension. What is the force required to stretch a spring whose spring constant is 100 Newton meter by an amount of 0.5 meter? So F equal to kx and F equal to 100 times 2.5, so force is 50 Newton. 120 kg object is suspended by two identical springs having spring constant 80 Newton per meter. What is the extension of the spring A and B? F equal to kx, so x is 15 meter, but is only per one spring. So in A, the spring is directly here, so I use 15 times 2 equal to 30 meter. And B is divided by 2 because it's divided by 2. 15 divided by 2 is 7.5 meter. Thank you for listening my presentation. Bye bye.
Oh yeah, Zell.
Today I'm gonna talk about work, energy, and power. Let's start with work. Okay. We can calculate work by using the equation W equal F times S. F is force, S is displacement or distance. Work unit is in joules. Okay, for example, if I apply 10 Newton force on an object and the object moves 5 meters long, so how much work applied by my force? Okay, so we use the equation W equal F times S. So force equal 10, distance is 5, so work done is 50 joules. But if there's a friction on the surface, how can we find work done by friction force? Okay, we use the same thing. W equal F times S. Friction force is negative because the object is moving from left to right, but the friction force trying to make the object moving from right to left, so is in the opposite direction, so it's negative. Negative 5 times distance 5 is equal negative 25 joules is work done by friction force. Okay, next is power. Power is just how much work can be done in a unit time. We can calculate power by the equation P equal W over T. W is work in joule and T is time, minute, hour, seconds, whatever you want. And the unit of power is joule per time, mostly joule per second. For example, if I applied force 10 Newton to an object and the object moves 1 meter in 2 seconds, how much power happens here? Okay, power is equal work over time. Work is equal force 10 times distance 1, time is 2 seconds, so over 2, and the answer is 5 joule per second is power applying. Okay, next is energy. There is many types of energy in the universe, but we are focusing on 3 of these: gravity potential energy, spring potential energy, and kinetic energy. conservation of energy is about energy cannot be destroyed or made in the universe. Okay, I'm gonna talk about that later. First, gravity potential energy. If there's height and gravity, there's the mass. The mass always has gravity potential energy. We can calculate that by the equation gravity potential energy is equal mass and gravity times height. Okay. Next is spring potential energy. Okay, if a spring compressed and has a distance x far away from the equilibrium distance, and the spring always has k, the spring constant, we can calculate spring potential energy by using the equation 1/2 times spring constant times compressed distance square. Yeah, that's all. Next is kinetic energy. If there's a mass moving, there's always a kinetic energy, always, no matter how much. Okay, the last thing that I'm gonna talk about is conservation of energy. For example, if an object is moving from point A to point B, whatever distance, and there is no energy loss or work applying on the object on the way, the total energy at point A is gonna be equal to the total energy at point B. Yeah, this is true, but in everyday life it's not always like this, because there's always energy loss or adding energy to it. Like this, if an object is traveling from A to B, there is some amount of work applied on it. It's not gonna be equal. The total energy at A and B is not gonna be equal because there's work applying on it. So total energy is at point A is gonna be equal to total energy at point B plus the work applying. Okay, for example, if an object is moving from A to B and there's a friction on the ground, the energy at point A is gonna equal to energy at point B plus work done by friction. And the friction force is opposite from the moving direction. It's moving from A to B, but the friction force is trying to make it move from B to A, so it's in the opposite direction, so the friction become negative and the work is also become negative. Negative work is mean the energy is not the same at A and B. It decrease because the friction, it didn't disappear or destroyed, it just be converted into another form of energy. If you slide something on a floor that has a friction, there's gonna be sound and heat, so the kinetic energy is gonna be transferred to thermal energy and maybe sound energy. Yeah, okay, it may sound easy, but to calculate the total energy at point A and point B is not that easy. And the thing is, the work done is much harder to find in real life, so yeah, don't miscalculate and always write the given. Goodbye.